Hello students, in this video we are going to learn the standard form of Boolean algebra. Now what is this standard form? A Boolean function, if all the terms of the Boolean functions are joined with the same operator, then that term is said to be in the standard form. In Boolean algebra, there are two logical operators which are binary, that is AND and OR. So, in a Boolean function, if all the terms are added and that each term of that functions are in the form of product, then that function is said to be sum of product. And if all the terms are multiplied and each term are in the form of sum, then that is said to be in product of sum. Sum of product, it is also known as SOP. Product of sum, it is also known as POS in its short form. Now let us see what is SOP. SOP means sum of product. Sum of product means, suppose there are three terms. Let us say these are three terms, and all the three terms are added. So it is the sum of the terms, and now each term are in the form of product. Let us say xy, x naught z, y z naught. I am just taking the variables like that. So here what you see, each term is in the form of product, then we can say that it is sum of products. In the same way, let us say there are three terms and each term is multiplied. Now each term should be in the form of sum. Let us say x plus z, y plus z naught, y naught plus z naught, x plus y naught, any term. And what you see, it is product of the sums. So this is product of sums. Now these are two standard form, that is sum of product and product of sums. Let us see one more question. If I ask you xy plus xz, y plus z, suppose this is the function, and if I ask you, is this in the standard form, then the answer is no. No, this is not in the standard form, because here you see it is plus operator is here and here it is the multiply. So standard form says that all the terms must be joined with the same operator and all the terms will be in the same form. Means this term is in the form of multiplication, this term is in the form of multiplication, and this term is in the form of sum. So it is neither sum of product nor product of sum, but we can convert it in the standard form. Let us see how we can convert it in the standard form. We convert the same function in two standard form. First I am converting this function in the sum of product, then I will convert the same function in product of sum. So this is a function x y naught plus xz y naught plus z. I want to convert it in the sum of the product. Then how we can do this? There are two distributive law. You need to remember the distributive law, because distributive law is very important. It is used to convert any function into sum of product or product of sum. There are two distributive law. For the reference I am writing first distributive law, x plus yz is equal to x plus y x plus z. Second distributive law is x into y plus z is equal to xy plus xz. These are two distributive laws. Distributive distributive laws. These distributive laws are used to convert any function into the standard form. Now let us apply these distributive law in our question. Here you see that it is already in the plus, so there is no need to convert this operator. Here I have to, if I multiply this term with each term of this bracket, then it will become sum of the product. So for that purpose, here this is the law, x into y plus z equal to xy plus xz. Now look at here, let us say it is x into y plus z, x, this into this, this into this. So we are applying this law at this point. So here we will get it equal to xy naught plus xzy naught plus xzz. It is xy naught plus, I am arranging the term, xy naught z plus z into z is z. Look at this. Now you have reached sum of product. Sum of products. So this is the standard term of Boolean function. You can get this question in your examination also, to prove this LHS equal to RHS. So this is the most popular question which you generally get in your examination to prove the relation. Now I am converting the same function into the product of sum. The function is xy naught plus xz plus y naught plus z. Now this is a function. I want to convert this function into product of sums. So here we are applying this distributive law, x plus yz equal to x plus y, x plus z. So this is the distributive law which is required to be applied in this situation to get the term in product of sums. Look at very carefully. This is sum of product, and here this is product of sum. Likewise here it is product of sum, and this is sum of product. So by applying the distributive law, you can easily get the standard form. Now I am applying this law in this situation. X plus yz is equal to x plus y into x plus z. Let us consider the whole term as x. Let us consider it is, say, x. This term let us say y, and the whole term let us say z. So what do you get? X plus yz. So x plus y, x plus z according to distributive law. So applying the distributing law over here, you will get x y naught plus xz, x y naught plus y naught plus z. Again apply the distributive law over here. This plus this, this plus this, this plus this, this plus this. So you will get x plus x, x plus x plus x means this plus this, x plus x. Now this plus this, x plus z. Again y naught plus x, y naught plus x. Again y naught plus z, y naught plus z. Now here also apply the same, this plus this, this plus this. So here you will get x plus y naught plus z, y naught plus y naught plus z. Now you will get this term. Let us simplify it. X plus x is x, it is x plus z, it is x plus y naught, it is y naught plus z, it is x plus y naught plus z, y naught, y naught, y naught, so y naught plus z. There are two common terms. Let us remove one because the law is, here I am applying idempotence law, x plus x equal to x, x into x equal to x. So we have removed the duplicate term. Now you have got x, x plus z, x plus y naught plus z, and x plus y naught plus z. So this is what? This is product of sum. See, all the terms are multiplied, so the product exists between all the term, and here each term are in the form of sum. Here it is in the form of sum, it is in the form of sum, it is in the form of sum. All the terms are in the form of sum. So we can say that it is product of sum. Now you will ask how this x is in the form of sum. So if I ask you x, can we write it like x plus 0? Yes. So we can say that this term x, it could be in the form of sum. In the same way, x, it could be in the form of product also, x into 1. So the variable, single variable means a term which is consist of single variable, that can be written in the form of sum also, and that can be written in the form of product also. So we can say that this is also in the form of sum, this is also in the form of sum, this is also in the form of sum. So in this function each term are in the form of sum, and the product of each term exists, then this is in the form of product of sums. So in this way you can convert any of the function into the standard form. Standard forms are sum of product and product of sums. Now at this particular point, one thing I also want to make you clear. Another important term we use in Boolean algebra. Actually this topic is not in your syllabus, but at this point of view it is required to be covered, because without this topic Boolean algebra will remain incomplete. That's why I am covering this topic. You will get the question from this topic in your IIT JEE mains exam also. Means in IIT exam you will find the question from this topic. One question from Boolean algebra comes in your IIT exam. Remember it. Second is canonical form of Boolean algebra. Canonical form of Boolean algebra. Now what is this canonical form? Canonical form says that function should be in its standard form. That is, a function, a Boolean function must be in sum of product or product of sum. So a function must be in its standard form, and all the terms contain all the variables of that function. For example, I am just telling you, there are two canonical forms of Boolean algebra, that is minterm and max term. What is minterm? Minterm is canonical sum of product. Max term is canonical product of sum. Again, I am telling you the definition of canonical form. You just write down in your notebook. A function is said to be in its canonical form if it is in its standard form and all the terms contains all the variables of the Boolean function. For example, I am just continuing the min term. Suppose there is a function x plus xy plus yz. Let us say this is a function. Okay. If I ask you, is this in the standard form? Yes, then your answer will be yes. This is in the standard form, that is, this is in the sum of product. Sum of products is term in the form of product, then we can simply say that this function is it in standard form and that standard form is sum of product. Now if I ask you, is this function is canonical? Then your answer is no. Why this function is not canonical? Because canonical function says that all the terms of the function must contain all the variables. For example, in this functions there are three variables x, y, z. This term is not having y and z, this term is not having z, and this term is not having x. That's why this is in the standard form, but this is not in the canonical form. But we can convert this function into the canonical form. Let us show you how. Okay, first I am just getting you the answer. Without doing anything, I can write the canonical form of this function. How? Let us see. How many variables are missing with this term? Two variables are missing with this term, that is y and z. So we can write all the combination of y and z with the term. Means it could be x is already here, it could be yz, or it could be x y naught z, or it could be x y z naught, or it could be x y naught z naught. So 4 combination of yz can be possible. Now here one variable is missing, that is z. So it could be x naught y is already here. So it could be x naught y z, or it could be x naught y z naught, because z is missing. So it could be in the form of z, or it could be in the form of z naught. Here also x is missing. So here two combination could be possible. One is of x, another is of x naught. So we can write this plus, for this it is x y z naught plus x naught y z naught. Now apply the idempotence law, x plus x equal to x. So duplicate term we will remove it from the expression. Is there any duplicate term over here? Let us see. X y z, no. X y naught z, x y z naught, x naught. This two terms are duplicate. Let us remove one. These two terms are duplicate. Let us remove one, because the property is x plus x equal to x. Now there is no duplicate term. So we can say this x y z plus x y naught z, the second term, plus x y z naught plus x y naught z naught plus x naught y z plus x naught y z naught. Now look at very carefully. This function is in the form of sum of products, and look at this, each term of the function containing all the variables. Means in this function there are three variables x y z. Look at here, x y z, 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 x y z. Means all the terms are containing all the variables of the function as well as it is in the sum of product form, then we can say that it is canonical sum of product, which is minterm. Now the question is this: how this term came, how I have directly written this term. So I should show you. I can write this x into 1 plus x naught y into 1 plus y z naught into 1, because x into 1 is x, so there is no difference. Again I am writing x, this one I am writing y plus y naught, this one I am writing z plus z naught. Same here, x naught y is here. For this one I am writing z plus z naught, means I am writing the combination of that variable which is not present over here. In the same way, x is not is present over here in this term, so I will write this one as x plus x naught. Okay, now simply solve the bracket, you will get this term. Look at this, x naught yz, x naught yz, x yz naught, x naught yz naught, means now you simply open the bracket and multiply as you do in mathematics, you will get this function. So this is the canonical form of the standard form. Canonical forms of Boolean algebra says that a Boolean function must be in its standard form and all the terms of the Boolean function must contain all the variables. Now let us see second example. If I ask you x plus y, x plus z, and let's say y naught. If I ask you, is this function is canonical function? The answer is no. Why? This function is in standard form. The standard form is product of sums. This function is in product of sums. But this function is not canonical. Why this is not canonical? Because all the terms of the function is not containing all the variables. Now we can directly write the answer of this. Let's see how. Which variable is missing over here? The z. So it could be z or it could be z naught. Just write both the combination. X plus y naught plus z. This could be the one term. X plus y naught plus z naught. This could be the second term. Likewise here, y is missing. So the combination will be x plus y plus z. Another will be x plus y naught plus z. Here x and z are missing, so it could be, there could be four possible combination of x and z. This combination will be x plus y naught plus z. Second will be x naught plus y naught plus z. Third will be x plus y naught plus z. Y naught plus z naught, and another could be x plus y naught plus z. Means one is x naught, another is z and z naught. So these are the four possible combinations. Now remove the duplicate term if any. These two are duplicate. I have removed one because x into x is x, and anyone, this is duplicate. I have removed this one, and this one is duplicate. I have removed this one. Now there is no duplicate term over here. Again this is duplicate. Again I have removed this one. Means all the terms are duplicate. I have removed one. Now you have got x plus y naught plus z another term is x plus y naught plus z naught, another is x plus y plus z, another is x naught plus y naught plus z. Now look at very carefully. It is what? It is product of sums. All the terms are in the form of sum, and there is product between all the terms. Then we can say that it is canonical product of sum, which is equal to max term. Now again the question is there, how I have directly written this term. Let us see. I can write this function like this, plus 0, because the property of 0 is x plus 0 is x. So there is no difference in this term. In the same way, x plus z plus 0. In the same way, y naught plus 0 plus 0. Again, I am writing this function like this. For this 0, I am writing z naught. Means the variable which is missing over here, I am writing the combination of that. So z into z naught, that is 0. That is a complement law. So 0 can be written like in this way. In the same way, x plus z, y is missing. For this 0, I can write y naught. In the same way, y naught, here x and z is missing. So for 1 0, I am writing x naught. And for second term, I am writing y naught. And if you simplify this function, you will get this. Here simply apply the distributive law. Means x plus yz to x plus y, x plus z. You will get this term. In the same way, x plus yz, x plus y, x plus z. You will get this term. So by applying the distributive law, you will get this term in this function. So in this way, you will get the canonical form of any standard form of Boolean algebra. Let us summarize. Don't be confused. Standard form and canonical form. What is standard form? Standard form says that all the terms of the function must be connected with a single operator. Either it could be plus or it could be multiply, and each term of the function should be in the same form. Either it should be in the form of product or it should be in the form of sum. So if all the terms are in the form of product and sum exists between these terms, then we can say that it is sum of product. Sum of products. Likewise, if product exists between the terms and each term is in the form of sum, then we can say that it is product of sums. It is product of sums. So these are two standard form of Boolean algebra. Now important point, if we want to convert any function into the standard form, then distributive laws are used. There are two distributive laws. In first distributive law, we distribute the plus. In second distributive law, we distribute the multiply. So remember the distributive law like this. There are two distributive law. In one distributive law, we distribute the plus, and in another distributive law, we distribute the product. So x plus yz or x into y plus z. If you do simple multiplication of this bracket, then what is this? X into y plus x into z. So how it comes? You have distributed the product between these two terms. In the same way, distribute the sum between these two terms. You will get x plus y, x plus z in this way. So these distributive laws are used to convert SOP into POS and POS into SOP. Like here, in this function, I want to convert into the sum of product form. Then what we will do? We have applied the distributive law over here. So this into this, you will get this. This into this, you will get this. Z into Z is Z. So this is the form which is in the form of sum of product. In the same way here, if we want to convert it in the product of sum, then we have applied this distributive law. We have distributed this plus sign, means take this variable as x, the whole term as y, the whole term as z. So x plus yz, this plus this plus this, x plus y, x plus z, x plus y, x plus z. Again apply x plus x, x plus z, y naught plus x, y naught plus z. You will get this term. Again here x plus this term, y naught plus this term. You will get this term. Remove the duplicate term, and you will finally get this function. This is the product of sum, that is a standard form of Boolean algebra. Now canonical form. Canonical form of Boolean algebra says that a function is said to be in canonical form if it present in its standard form, that is a function must be in sum of product or product of sum, and all the terms of the function must contain all the variables. Like here yz is missing, here z is missing, here x is missing, and when we converted this function here, now you see that all the terms are having all the variables, and this is also in the form of sum of product. So a function is in sum of product as well as it is canonical, that is all terms are containing all the variables. That's why this function is considered as minterm. In the same way here, this function is in the form of product of sums, and when this function is converted into the product of sum with the canonical form, because all the terms are having all the variables, then we can say that this function is in canonical product of sum form, and the canonical form of product of sum is known as max term. Thank you. Do this question by yourself.